Hey guys, so this video is again to clarify a confusion the students have regarding the signs of vectors. So let's say you have a vector A, right? Now A points, this is called the first quadrant, the second quadrant, the third quadrant, the fourth quadrant. So A points in the first, A is in the first quadrant. This is the x, this is the y axis. So the vector A has a positive x component. Okay, so ax is positive, ay is also positive. Okay, now let's say that A points let's say we have another vector. Let's use another vector. Let's say this is your vector B. I have a vector B that points in the second quadrant. So again, your x and y, and this is B. So the vector B has, so this is its projection. Okay, so its projection on the x-axis is this, on the y-axis is this. So Bx is negative. So the convention, this is positive direction, this is negative direction. Any vector that points towards this direction or has a component that points in this direction will have a negative x component. So so then Bx is negative, By is positive. Okay. Then let's choose another vector. So let's say that we have another vector that points in the third quadrant. So let's call that C. Now C has so this is its projection on the x and this is y. So they both are negative. So Cx is negative and Cy is negative also. Similarly, if we have a vector that points in the fourth quadrant, okay, D, the vector D has a positive. So this is its projection on the x, which is positive. So dx is positive and dy is negative. Okay. Now we can take an example of a vector. Let's stick to the first vector A. And so in the previous video we talked about the sines and the cosines. So let's say that you stick with this angle theta, right? So let's call this vector A. Now in the first quadrant, now we'll try to move this to the second quadrant, the third and the fourth by adding some factor with the theta, right? So let's say that you add 90 degree. So if A is in this quadrant, so AX is A cosine theta, right? So AX is equal to A cosine theta and AY is A sine theta. So this is what we've already seen, right? Now let's add so this is where the negative, you can see where the negative signs come in, right? So so let's add let's add a 90 degree with the theta. So that we bring this guy, we push this guy in this quadrant. So we get this now. So it's almost like perpendicular to that. So then A is this. So this is like theta plus 90 degrees now. So then you can see that AX will be equal to A cosine of 90 plus theta. Okay. Now you can use a calculator. We can use a trigonometric relationship also to see that this gives a negative sign. So let's say that theta is let's choose theta to be like 30 degrees, right? So then this is like 90 plus 30. We can use the calculator also. This is sometimes easier to just look at an example. So this would be 90 plus 30, which is 120. So cosine of 120. So we expect a negative sign now, right? Because it's in this quadrant. The x component in this quadrant should be negative. So cosine of 90 plus 30 is 120. So you get a negative sign here, right? So the calculator tells you if you stick to this angle, right? So if you stick to this convention that, okay, I'm always going to measure this angle relative to the positive x-axis, then you always have a cosine and a sine here, and if you measure this angle, the calculator will give you the negative sign, or if it's positive. So this is your a. So negative a sine theta. Sorry, negative a cosine theta. So the calculator gave us this negative sign now. But you should know how to put in the negative sign by hand, right? So let's write this. So you should know how to write this negative sign by hand. Because in some questions, let's say there's a displacement in this direction, right? And the question gives you this angle, right? So you can also figure out this angle, that's also correct. But if you stick to this angle, then you have to put in the negative sign by hand. The calculator won't give you a negative sign. Okay, so so AY again is, so this was your AX, and AY is, so sine of 120, you can see sine of 120 will still be positive. So then AY is still a sine of 90 plus theta, which is still a sine theta. Okay. So again, you can also use a cosine of a plus b to see that this this pops out also from that equation. Okay, the negative sign. Okay, now let's say we add, so we want to bring it to the third quadrant now. Let's say we add a 180 degree with it. So instead of theta, so now a is in the third quadrant. So let's draw that. So you get, this is your a. Now it's in this quadrant. It's like 180 plus theta. Okay, so there you go. So your angle is 180 plus theta degrees, right? Now 180, so we took an example of 30 degrees, right? Now if you add 30 degrees to 180, you get 210, right? So you'll see that cosine and sine for 210 both will be negative. Sine of 210 is negative, and cosine of 210 is also negative, right? So you get AX equals a cosine of theta plus 180. So that's going to give you again a negative a cosine of theta. Okay, and a y will be a cosine of theta plus 180 degrees. That's also going to give you negative a sine theta. So the negative sign again pops out because of the fact that you're measuring the angle relative to the positive x-axis. And again, if you use this angle, you have to put in the negative sign by hand. Right. Now let's do the last thing. Let's add 270 degrees. If you add 360, you come back to where you were. So, but we're going to add 270 degrees. So then you'll bring your vector in the fourth quadrant, right? So this is your vector A now, okay? So now you're measuring still your angle relative to this. So you get now 270 plus 30, right? Again, this is an example. We can also use the trigonometric relationship of cosine A plus B, but I'm just using the calculator as an example, okay? So 30 plus 270. Now we added this angle is theta plus 270 degrees now, okay? This whole thing. Now, if you add the 30, for example, to 270, you get 300, right? So let's see. So what do you expect now? You expect sine, the cosine to have a positive and the sine to have a negative. So cosine 300 is equal to, it gives you a positive, and sine 300 gives you a negative. So there you go. So we have, again, AX is equal to a cosine of theta plus 270. That's just going to give you a cosine theta, and AY is a sine of theta plus 270. That's going to give you negative a A sine theta. So now you can see that this is just consistent with what we saw, right? So Cx, so these were different vectors, but you know they both are positive over here. In this quadrant, the cosine, the x component is negative, the y component is positive, right? So it's consistent with what we saw. In this quadrant, they both are negative, and in this one, one is the x is positive, the y is negative, right? So again, this is due to the properties of cosine and sine. And hope you liked the video. This was it for this concept. So hope you liked the video. Please ask any questions in the comments if you have, and subscribe.